Hi guys, today I want to talk a little bit about open source. So I'm just going to go through an introduction and try to explain to you a little bit about open source hardware and software. So let's get started. So first of all, the most obvious question is what is open source hardware? Um, and the definition is basically it typically describes the designs and design artifacts that are freely available, modifiable, and shareable. So just a few examples of some open source hardware. We've got one of the most famous ones is Arduino. Many of you will be quite familiar with that. It's been around for quite a while now, and you'll find a lot of these cheap Arduino microcontroller boards available online from a lot of online retailers, and even your local electronics store will probably stock it. They're that widely available. Then you might have heard of Adafruit. They're they're a little bit newer than Arduino, but they've also adopted a lot of the open source ideals, and they design and produce various electronics for hobbyists, and they create all sorts of boards, sensors, and circuits that you can easily integrate, and a lot of the times interface them very simply with an Arduino board. I think they also make their own version of Arduino. There's actually quite a few Arduino clones out there that feature a lot of different features. So you find some manufacturers that add in other circuits onto the boards, for example Bluetooth or Wi-Fi or any other built-in sensors. And similar to Adafruit SparkFun, they also do very similar. They design and produce various electronics for hobbyists. A lot of the time you'll find they'll put the open hardware logo, or they'll state it in their designs. I mean, a lot of the times they'll share the schematics and the PCB layouts, and which you can download and use and modify yourself. So those are some examples of companies that produce open source that are quite established, and you can find a lot of available info from their websites. So second question is, what are design artifacts? So when you talk about hardware design, there's a few steps involved. First of which is a schematic. Now a schematic is it's an electrical schematic. How can one explain that? It's basically an overview on how all the various parts are connected, specifically each particular pin on the microchips or resistors or components, and how they're connected to the other components. So that's one of the most important artifacts that you'll find. It's the most basic. The second most important one is the PCB layout. Well, maybe not second most important, because PCB layouts can be very complicated and they take a lot of time to design and to lay out. I mean, you find a lot of science and a lot of art goes into laying out boards like these. This is some kind of microcontroller board. You can even see there's pads over here where you find a flat pack chip being placed for a flat pack chip, and here's another space for another flat pack chip, which is oriented 45 degrees. So these are quite important. These files, PCB layouts, you can send directly to manufacturers, and they'll create a board that matches that exactly. And the third design artifact is the bill of material. This describes which exact components get used on the board. So what you'll find is that there'll be references for each component which will refer to items in the board. So for example, if you send all these files to a manufacturer, normally the manufacturer won't be interested in the schematics. He'll be interested in the PCB layout and the bill of materials. And the bill of materials will be directly related to the items that are specified on the board layout. So the manufacturer knows which component goes exactly into which spot. So those are the three design artifacts in hardware. So how do you share these artifacts? Well, the designs that are made available should include editable sources. So editable files, for example, the not usually the board layouts. The board layouts themselves can be formatted for certain design packages to be read in, while if you also find PCB layout files that are not designed to be editable. For example, if you export from your design packages to production files, then those are usually not easily made editable. So to make them editable, you simply distribute the source file that you use to create the production layouts. So you find a lot of communities online that provide online tools that let you design and share the designs at the same time. For example, EasyEDA is quite a popular, easy to use software tool that's based in the cloud that lets you, without downloading any software, you can do it on their website. You can lay out your, you can build your schematic, you can lay out your board, and you can edit your bill of materials from where you can directly order that board that you designed online and pay for it and have it delivered, all from that one simple to use website. Circuit Maker does something very similar, and OSH Park is quite similar, except that they don't have a schematics editor, but they allow you to upload the outputs from Circuit Maker or EasyEDA or any other, like EagleCAD or any other circuit or CAD software. So OSH Park lets you upload those files and share them automatically. OSH that stands for Open Source Hardware Park. So it's a place where you can share your designs and also order the parts online from their production facilities. So what are some of the pros of open source hardware? Well, first of all, the designs are free. It's a great learning experience because you get to see exactly which components are connected and what the values of those components are, and you can, there's a certain amount you can learn by just looking at other people's designs, and from that you can infer certain things, and in that it lets you learn some basics about what may be good practices, for example. Another big pro is that it's often a lot cheaper to purchase your own or to order your own hardware. So it lets you, you can edit it, you can design it, and it's many times cheaper than buying off the shelf parts. So costs is a big factor, that when you do order your hardware, you'll find that it's a lot cheaper than what you can get in the shops. Another thing is you get access to a lot of proven designs. So you'll find a lot of guys out there that have years and years of experience, and they just make some really cool things available. And these designs are, have been tested by them, and they probably have a lot of experience, and that's what makes these designs quite reliable in many cases. And the other pro is that if you produce any hardware from these designs, you can sell that hardware without any restriction. So that's quite a cool pro, I find. So next thing, we'll look at the cons of open source hardware. Well, documentation is often minimal, and sometimes you'll be lucky if someone has a blog post about it and explains the things that you might be interested in. So a lot of the times you'll have to try to understand the concepts of the circuit through other means. So yeah, documentation can be minimal. And be sure you can fill the gaps yourself. So you might be in for a bit of a dig into data sheets and a little bit of math to figure out what the circuit's limits are, or what it could be used for potentially if you have specific applications. Then getting the parts can sometimes be tricky. And it becomes quite interesting when you take someone else's design and they have specifically chosen some parts, and you think to yourself, well, I can probably make it cheaper, or I maybe don't need that much precision, or I want to change it a bit. And in that case you can, because many times those parts that they choose in their that the original designers choose in their designs might be not exactly what you need, or something you cannot access, or might be really expensive to source. So it's always good to be able to change a few parts. And yeah, sometimes you need to some parts are just out of production, and you need to find or substitute the parts that are specified in their designs. And so that could be a rabbit hole sometimes if you're uninitiated, or if you're new to the scene. Then there's a lot of time that might be needed to find the right parts. So yeah, that's the basics of open source hardware. Now I want to have a quick chat about open source software. I find it's quite related to the way open source hardware works, except it does get a little bit more complicated. So we're going to have a quick chat about that now. So what is open source software? So open source software basically packages of code that can be accessed, modified, and distributed freely. And it's complicated, and I'll go into that in a minute. So let's have a quick look at some examples of open source software. We've got Linux, we've got Firefox. You'll be surprised, not the entire Chrome browser is open source, only parts of it. Then you get Inkscape, for example. GIMP is quite a popular image editing tool, and Kdenlive, which is an open source video editor, which I personally use to edit my videos. And KiCad, which is a CAD electronic design tools, so that's also something I use quite often. Also Inkscape I use a lot. Yeah, so you might have heard of some of these, and you'll be able to access or find the code online for all these products, and inspect the code and compile your own versions and do all sorts of cool stuff with that. So that brings me to, why is open source complicated? Well, first of all, open source software is an umbrella term, so it can get quite specific, because what you'll find is that various software licenses exist for open source specifically. I'll go over a couple here, many of which you might have heard of: GNU GPL or LGPL, BSD or FreeBSD, MIT, Apache, Mozilla, and Creative Commons. And I've got a link here to read up a little bit more about this. opensource.org maintain quite a bit of information about open source software, and they link to all sorts of information that's relevant to that. So I encourage you to go have a look if you're interested in the open source scene, to find out a little bit more about these different licenses and which ones to choose if you go that way of open sourcing some code. So the next question is, how do you get involved in open source? I mean, it's starting to get complicated, and you know, it's there's so much out there, and where do you just get started? Well, quite simply, if you're interested in any software that you know is open source, download the code, have a look at it, and if you have some software skills, it might sound a bit daunting, but a lot of the time there are straightforward, easy to follow instructions on how to actually run the source code, and it can be quite interesting. It can be quite a learning experience. So just download or clone the software from a repository and start checking it out. And hey, if it's something you think you can do, give it a whirl. So next step is, once you've cloned the software, it's actually making modifications is the hard part, because many of the open source repositories, they have certain coding standards, they have certain rules on how to go ahead when modifying code. So that's usually stated in their terms and conditions and that sort of thing. And there are, you might find a lot of different tools that you need to get hold of in order to actually to finish modification. For example, if you need to write tests, then you'd need to know how to run tests and understand what the output looks like. And then, you know, get involved, and you'll find a lot of the repositories out there, they feature a list of sort of features or issues that they'd like to tackle for that software. And the thing is, it's all community driven. You know, you can sign up, you can download the code, and then you can actually you can request that your code get merged in. And what they'll do, they will actually read your code. They'll read the changes that you made, and based on whatever conditions they have, they might accept it or reject it. And that's quite an interesting learning experience, which I've done a few times myself. So just a quick overview of the open source project process. So basically, just the way it goes is you have someone who writes some code, particularly the owner, for example, and he that code goes into his code base. Then he makes it open source, and what it allows his peers to do is to review it, and subsequently they can submit improvements, i.e. they can make the modifications needed, add features and all sorts of things, and then they can submit them back to the owner. And once the owner's reviewed them and accepts it, then those changes go straight back into the original code base, which now becomes the better code base. And that's basically the open source process in a nutshell. So let's go over some of the pros of open source software. You'll find, okay, they have no monetary cost, so free, great. It allows you to inspect the source code. Well, obviously, if they let you download it, then you can inspect it. And awesome thing about being able to inspect source code is that you can learn so much about how certain applications are put together and what methods they use to build an application. It's quite insightful to be able to inspect other people's code, especially if it's a community of coders, and it gives you quite a strong insight into how kind of large scale coding works. Another pro is that you can modify the code to your own particular needs. So let's say you're running a small business and you need maybe a version of a code editor, but the editor doesn't allow you to do a certain thing. So you can go in, make the change yourself, and use it internally. And if you find it useful, you can submit that back to the original owner, and who knows, maybe they'll accept it into the code base for the whole world to use that particular feature that you added. So it's quite powerful. Another pro is that you get to fix any issues in the code. So if you come along and you try something and it fails, and you wonder why, and and it might actually be a fault in the code. That's you might have discovered a bug. So many times you can actually unknowingly fix inherent issues in the code. And of course, you contribute the fixes back to the community, which essentially is back to the world. And that's quite amazing to be involved in an open source project. It gives you quite a great feeling that you're kind of making a change for the larger good. So next we'll look at the cons of open source software. So we've got the Grumpy Cat who says, how about no? But Grumpy Cat's always Grumpy Cat. So open source is sometimes hard to get running. You'll find sometimes that there are many steps involved to get it to get the source code to actually run, and because of that, the documentation might be confusing because it's so complicated, and there might be things you don't understand along the way, like certain tools that you need to use in order to get it running. They might not have all the documentation that you need, and it might be written in an informal way, which could be maybe not for a beginner type person. And time-wise, it's not always the best solution, especially if you're using it in a commercial environment. To use open source software can be a little bit problematic because you don't find enough support. You'll have some forums and it'll just be a little bit of a struggle sometimes. So not always the best solution. And yeah, that brings me to my conclusion. Wow, it's been quite a long video already, and I'm just gonna go over this quickly. So open source is a great way to get hold of and to distribute ideas with the added investment of time and research, if permissible, is often a great way to get started for the hobbyists and small businesses. With massive commercial ventures out there that have started promoting the use of and development of open source or free content is on the rise, and the monetization of these products is also being changed, all for the benefit of the customer. And it's really an exciting time to be living right now. You know, open source hasn't been around for a very long time in its current incarnation. So, and it's only getting better with companies like Google really driving it so hard, and you find a lot of smaller companies that are just they're just kind of getting together in an informal way and releasing software that people find useful. So it's, you know, as time goes by, you just get more and more and more, and it's incredible, and there's so much out there to learn from. So yeah, I just wanted to thank you guys for listening to my rant about open source. And yeah, if you found this valuable, I might be making a follow-up video going a bit more in depth about open source software, and maybe a little bit more in depth about open source hardware. I think there's a lot of topics still to cover in the meanwhile. So yeah, please leave your comments, give it a big thumbs up, and subscribe. Anyways, thanks for watching, guys. Cheers.